Hello everyone, myself Pranjal Sharma, and in today's video we will learn on the basic mathematical tools required for introductory level physics. So in physics, mathematics is very important. Actually, mathematics is the language of physics. In physics, everything is expressed in terms of mathematical equations. So mathematics is the basic requirement of physics. And now we need to learn some advanced mathematics which we have not studied earlier. That means you have not studied in up to class 10th level, and that one particular branch is the calculus. Calculus is a branch of mathematics which was developed by two persons independently at the same time. One was Sir Isaac Newton, we all know him, and another was Leibniz, Gottfried Wilhelm Leibniz. So these two persons simultaneously developed the branch known as calculus. Newton, in his book Principia and Optics, he had shown different mathematical techniques which are nowadays known as calculus. Similarly, at the same time, Leibniz, a German philosopher, also developed calculus. In generally, we have to learn two types of calculus. One is known as differential calculus. And another is integral calculus. So actually both are opposite to each other. Before going to discuss about this branch of calculus, we have to recall some basic concepts which we have learned in school level. Basically, we have learned about polynomials. So polynomials we often explain as Px, which is sometimes function of which may have form linear, suppose x plus of 1 or x plus of something. So the power of x in that case is 1. So this kind of polynomials are known as linear. Or sometimes we express quadratic polynomial, this time ax square. So generally it is ax plus b. It is a form of linear polynomial. In case of in case of polynomial which have a maximum power of 2, then in that case it is known as quadratic. Or sometime and we can write in this way different kinds of polynomials like cubic and so on. So it is a very vital concept. And another is we have learned some dependent and independent variables, like we express y in terms of x plus of, sometimes we often found this kind of equation, y equal to x plus of 1 or y equal to x square plus of something plus of 4 or something. So these are examples. So every time you change the value of x, then y will changes. So y is completely dependent on x. In this kind of mathematics, we consider x as a independent variable, and y is known as dependent variable. We all know it. So y is always depends on x, some independent variable. So we can express y as a function of x. Function of x means some polynomials of x. Or now if we change the value of x by a small amount, suppose x is changes by x plus a small amount delta x, then obviously the y will changes because we have changed the x value. So y will changes to some value y plus delta y. Suppose let's take an example here, y equal to x plus 1. So let's see if x equal to 1, then y equal to 1 plus 1 equal to 2. If y is equal to, see, if x equal to 1 plus 0.01, then y is equal to 1 plus 0.01 plus 1, that is 2.01. So y will also changes if we change the value of x. So in this way, if we change a small amount of x like delta x, then it will changes the value of y by some amount. Okay. Now what amount of change occur due to change of x? In this case, the change of y is y plus of delta y minus of y, right? So it is simply delta y, and it is occur due to delta x. The change of y due to delta x is equal to y plus delta y minus of y is equal to delta y. So this amount of y changes due to change of the value of x by delta x. Then we can find the relative change of y with respect to x. So delta y, change of y with respect to change of x. So we can calculate this ratio. Now what it means? What it actually means? In generally, if we draw a graph x versus y, since y is a function of x, so we will get some point, right? We will get some point. So for every value of x, suppose x1, we will get some value of y1. If I change x1 by a small amount plus x1 plus delta x, then y will changes to another value y1 plus delta y, right? So x will changes from x1 to delta x1, x1 plus delta x, then y will changes from y1 to y1 plus delta y. So here the change is, if we calculate, then this amount, this change is delta y, delta x, and this changes is, since it is y plus delta y, y1, sorry. So this amount is delta y. So we get, in this expression, we get, this is delta x, this is delta y, okay, and this is a right angle triangle. So here in this right angle triangle, delta y by delta x is what? It is nothing but the tan theta. It is tan theta. So this is known as slope of the particular curve. So if we draw a function, suppose y equal to fx, then suppose we draw a curve like this, then for some value of x it is y, for some value of y, x plus of delta x, its value is y plus of delta y. So now this is delta x, this is delta y, and tan theta is equal to delta y by delta x. Then this tan theta is known as the slope of the curve. So delta y by delta x, the change of y with respect to change of x is actually nothing but it gives the slope of the curve. Now if we change the value of delta x by a very small amount, if this delta x is very very small, in physics that term is known as infinitesimally small. What is infinitesimally small? It is smaller than any smallest number that you can imagine, but it is not zero. Okay, so delta x, in that case we can write delta x tends to 0, but it is not 0. And in this case, if we write limit of, we put the limit delta x tends to 0, then this ratio delta y by delta x can be written as derivative of y with respect to x. So dy dx, and this is our differential formula. Since y equal to fx, so dd x of fx. So this is an operator, remember, ddx is an operator. So in this way we can calculate the differentiations. So for any value of x, any function of x, we can calculate the differentiation of the particular function. Some standard formula of differentiations, say fx is equal to x to the power n. In that case, differentiation of x to the power n can be expressed as n into x to the power n minus of 1. So let's take an example. Suppose we want to calculate ddx of x. In that case, n equal to 1. So according to the formula, here n equal to 1, x 1 minus a 1, so it is simply 1 into x to the power naught, which is equal to 1. So ddx of x equal to 1. Or for n equal to 2, in that case ddx of x square, so according to the formula n equal to 2, x to the power 2 minus a 1, so 2x. Similarly, for n equal to 3, ddx of x cube, so its value will be 3x square. So in this way we can calculate differentiations of a function of x, which value is x to the power n. For some power of x, we can calculate its differentiation by using this formula. There are plenty of formulas available and which we need to use during the study of physics. I have added all the formulas into the video. Please pause the video and watch it. Now, so we have now studied on integral calculus. We have already studied the differentiation. Now we will study the integration. Integral calculus. Again, we write y equal to fx. So y is the some function of x. Y is equal to some function of x. So before going to this thing, we need to calculate some area. We have learned different formulas of area for different geometrical shape. Suppose I want to calculate the area of this region. Suppose its length is x and its two arm is x and another is y. So in that case, the area is x into y, right? Suppose I want to calculate the area of some complex region like this. In that case, we calculate the area by splitting that particular area into two geometrical shape, and the area of this is A1, this is a quadrilateral, and this area is A2. So we simply found the total area is A1 plus A2. Or if you want to calculate, suppose the shape of this region, then what will you do? Then you can simply find the area of this region, the area of this region, and area of this region. So we know the formula of areas of rectangle and triangle. So we simply calculate area equal to A1 plus A2 plus A3 for this all region. Okay. Now why we need to study the area, calculating area of different size, different shape? Because in integration we will calculate the area under a curve. Suppose here y equal to fx, so we plot a curve. Suppose y equal to x. So if I change the value of x equal to 1, then y equal to 1. If I change the value of x equal to 2, y equal to 2. X equal to 3, y equal to 3. In that case, if we draw the graph 1, 2, 3, 1, 2, 3, so this is a straight line, right? This is a straight line. If you want to calculate the area under this line, suppose from 0 to 3, the area under this line, then what will you do? You simply use the formula of the area of a right angle triangle, which is nothing but half into base into height. And from this formula we can calculate, since it is 3 and this is also 3, so half of 3 into 3, so it is 9 by 2. Okay. But what will happen if you want to calculate a area under this region? So you need to calculate the area of under this curve. So it is very difficult because it has no geometrical shape, right? So what will you do now? In that case, you have to split the area into numbers of strips like this. The thickness of each strip should be equal and small, such that the point from this line, the portion of this curve is a straight line within the strip, or this portion is straight line for this strip, this portion is straight line for this strip, and so on. In that case, if the thickness of each strip is delta x, suppose the thickness of each strip delta x, and the value of this portion is fx1, this portion is fx2, and so on. So area of this small strip is fx1 delta x1. This region is area of this region is fx2 delta x2 delta x, sorry. This region is fx3 delta x. So in this way you can calculate the area of all the strips, and finally you need to sum up all the strips to get the total area under this curve. So the total area in that case is total area A is nothing but fx1 delta x, fx2 delta x plus fx3 delta x, and so on up to, suppose we have n strips, so last term is nothing but f xn delta x. So all this term can be write into a concise form like summation of I equal to 1 to n f xi delta x. So area under this curve can be expressed as summation of I equal to 1 to n f xi delta x, where n is the number of strips, n number of strips. Okay. Now if you change the value, if you take the thickness of each strip such small, which is nothing but now if we consider the thickness of each strip is infinitesimally small, that is smaller than the smallest number you could ever think of, but which is not zero. In that case, you can replace this summation term by elongated s term and simply write fx dx, and this is known as, and this formula is this give the area of the area under this curve, and this is the integration, the integral formula, integration. Okay. Suppose we need to calculate the area of the curve from x0 to xn. In that case, we simply put the value x0 here and xn here. This is known as lower limit, and this is known as upper limit. Okay, when these kind of limits are applied, then the integration is known as definite integral. When there is no limit is applied, then in that case that integral is known as indefinite integral. And in case of indefinite integrals, we have to add a constant term along with the result, which is known as integration constant. So let's take an example. The standard formula of integration for x to the power n dx. We have already derived the differential formula of x to the power n, which is nothing but n into x to the power n minus of 1. In this case, for integration, its value is x to the power n plus of 1 by n plus of 1. But for this integration, we have to put a limitation, which is nothing but n cannot be equal to minus of 1. Okay. For n equal to minus of 1, this formula will not valid. Now, let's take an example. Suppose n equal to 1. So, since I have not written any kind of limits here, so we have to write a constant c, and it is known as integration constant. Okay. For n equal to 1, so x to the power 1, so it's simply x dx equal to, according to formula, x to the power n means 1, so 1 plus of 1 divided by 1 plus of 1 plus c. So its formula is x square by 2 plus of c. C is what? It is integration constant. Okay. Or for n equal to 2, then its value is x square dx. And in that case, x 2 plus of 1 by 2 plus of 1 plus c. So x cube by 3 plus of c. So in this way, we can calculate the integration of x to the power n. So let's see what will happen if we put some limits. Suppose I want to calculate x to the power, so suppose x dx from 1 to 3. We here fx is equal to, here fx equal to x, fx equal to x. So if we plot the graph for x equal to 1, fx equal to 1, so 1, 2, 3, 4, 1, 2, 3, 4, this is 0, 4, 0. Okay, so this graph will like this. Okay, so we want to calculate the area from this portion to this portion. This is 1, this is 3. So why we want to calculate the area of this region. Okay. Obviously, using the geometry, it is easy. So we split the term into this. Then this region is 1, so this is also 1, and 1 between 1 and 3 it is 2. So the width of this region is 2. 3 minus 1, 2. So area of this region is 2, and since it is 1, so this region is 2. This is 2, so the area of this region is 2 by 2. So it is simply 2. So total area is, this is 2, and this is 2 plus 2 is equal to 4. Now let's check if we get the same result from the integration or not. Here, according to the formula, since we put the limit, so we don't need now integration constant. We simply put the value of this. So x to the power n, x to the power 1 plus 1 divided by 1 plus 1. So it is x square by 2. Now we put the limit from 1 to 3. So here in this case, you need to put the limit, put the value of x, upper limit at first. Look, for the first term, we put 3 square minus of 2. We put the value of 3 in terms of x, and then putting the minus sign, and then we will place the lower limit, simply 1 square by 2. So this is 9 by 2. This is half. So taking the LCM, and 9 minus 1, it is 8 by 2. This is equal to 4. So look at the results are same. If this result, this method we have already learned. Why we require this complex method to learn physics? Let's take another example. Suppose we take a value for n equal to 2, x square dx. Okay. Now we want to calculate the value of x square dx from 1 to 2. In that case, the integration result should be like this. X 2 plus 1 by 2 plus 1, so simply x cube by 3. Again we put the limit 1 to 2, so it is 2 cube by 3 minus of 1 cube by 3, so 8 by 3 minus of 1 by 3, or it is 7 by 3, which is around 2.33. Right? Now we will plot it and calculate the area geometrically. So this is x, this is fx, here fx equal to what? X square. So for x equal to 1, for fx equal to x square, y equal to fx equal to x square. For x equal to 1, fx equal to 1, x equal to 2, fx equal to 2 square equal to 4. Okay. So x equal to 1, x equal to 2, we put 1, 2, 3, 4. So here for x equal to 1 it is 1, x equal to 2 it is 4. If we simply connect these two lines, it's a straight line. Then if you want to calculate the area under this region, then you will find that the width of this region is simply 1, and this region is, this is 1, so it is 1. Okay, so area of this region is 1. Area of this region is 1. This is 3. Since it is 1, it is 3, and this is 1, so it is half of 3 into 1, so it is 3 by 2. Here the area is A is equal to 1 plus 3 by 2, it is 5 by 2, so it is 2.5. So this result and this result are different. Why this difference arises? Because consider a wrong assumption. Let's check. Suppose we put x equal to 1.5, that is 3 by 2. In that case, fx equal to 9 by 4, which is 2.25. So if you put the value of 2.25, then it will not lies on this line. It will lies in between, somewhere between this region. So the actual line between 1 and 2 is not a straight line, but it is a curve like this. And actual formula of x square is like this. If you plot a curve fx equal to x square for x, then you will get a curve like this, not a straight line. So when you calculate by using geometry, then you will calculate the entire trigonometric portion, entire triangular portion. But in case of integration, it easily deduct the unwanted portion and it gives the result 2.33. So it is more accurate compared to this method when we calculate the area under a curve. For straight line, it gives correct answer. For a curve, the result will be more accurate using integration formula. Now we have learned the integration formula to integrations too. So I have added different integration formulas which we need to require while studying physics into this video. So pause the video and watch it. So why we need to study calculus in physics? Because it is important to study some parameters like instantaneous velocity, instantaneous speed, instantaneous acceleration. So those things are only understand through using calculus. We will in our later classes we will learn the formulas like velocity by this, acceleration by this, or in this way. So we need to learn integration as well as differentiation for studying physics. Besides calculus, we have to learn, we have to remember other mathematical formulas which we have learned in school. That means the area, volume and surface area of different geometrical set. Besides this, we need to remember the roots of the solution of quadratic equation. That means ax square plus bx plus c equal to 0, where x equal to minus of b plus minus of b square minus of 4ac by twice a. This formula will be required to learn physics. And also we need to remember all those trigonometric identities. That means sin theta, cos theta, tan theta, cot, sec, cosec theta. All these things, all the ratios of these trigonometric identities need to be remembered. So sin theta equal to perpendicular by hypotenuse, cos theta is equal to base by hypotenuse, tan theta is equal to perpendicular by base, and so on. And we need to remember the identity like sin square theta plus cos square theta is equal to 1. 1 plus of tan square theta equal to sec square theta. So these things should be required. And besides this, we need to learn some formulas like sin of a plus of b, a plus minus of b, sin of a plus of b or sin of a minus of b. In that case, the formula is sin a cos b plus minus of cos a sin b, or cos plus minus of b, a plus minus of b. In this case, cos of a cos of b minus plus sin of a sin of b. Using this identity, you have to calculate sin of 90 plus of theta, sin of 90 minus of theta, cos of 90 minus of theta, cos of 90 plus of theta. Okay. And also you need to remember, you need to learn the formula like sin of c plus minus of sin of d, which formula is 2 sine of c plus minus of d by 2 cos c minus plus of minus plus of d by 2, and cos of c plus of cos of d is twice cos of c plus of d by 2 cos of c minus of d by 2, and cos of c minus of cos of d is equal to 2 minus of 2 sine of c plus of d by 2 sine of c minus of d by 2. These formulas will be very important, and all these formulas you will learn in mathematics, so don't worry on it. You just need these formulas, so I have written down all these formulas. So these formulas we'll learn in mathematics, so I will not explain these things here. I just put the formulas. Besides this, you have to learn some special functions like exponential function, exponential function, e to the power exponential of x or e to the power x. Its value is 1 plus of x plus x square by factorial 2 plus x cube by factorial 3 and so on. So this is known as exponential function. Exponential function. Another is known as logarithmic function. Logarithmic function, where log of 1 plus of x minus of x square by 2 plus x cube by 3 and so on, where the condition is delta x is less than 1. And besides this, you have to learn binomial theorems. So binomial theorem is binomial theorem. So binomial theorem is, so simply you need to learn these formulas: 1 plus x to the power n or 1 plus minus of x to the power minus of n. In the first case, it is 1 plus minus of nx plus n into n minus of 1 by factorial 2 x square plus so on. In the second case, 1 minus plus of nx plus n into n plus of 1 by factorial 2 x square and so on. In both the cases, the condition is x is less than 1. So these formulas will also be required to study physics. So besides all these things, you have to remember all the preliminary triangular formulas, similarities, laws, and as well as Pythagoras theorem. So these are the mathematics required to study the basic introductory physics. So at this point, I want to stop this lecture. If you like this content, please press the like button. You can share the video. If you want more this kind of content, please subscribe the channel. And if you have any doubts, please write it down into the comment section. Thank you.